Thanks, everyone, for coming here today. This should be a cool session. We've been talking a lot about personal data and health data. But what Nicholas researches is the way that networks of people affect each other's health. Now, so you originally got interested in the question of how social behaviors sort of flow contagiously from one person to another. How did that happen? Where did that interest come from?
Well, it's a story I've told before, but I came up as a hospice doctor. So I'm, in addition to being a social scientist, I'm a physician, and I take care of people who are dying, or I did until a few years ago. And in the 1990s, I was at the University of Chicago, and I was paying house calls to people who were dying, and often they were being cared for by other individuals. And in my lab at the time, I was studying the widower effect, which is one of the oldest documented cases of interpersonal health effects. So if I die, my wife's risk of death goes up.
Right.
And sort of one day I became aware of the fact that actually the widowhood effect, which is my death causing my wife's death or vice versa, is a special case of a broader phenomenon. That actually it's not limited to dyadic effects, one person upon another, nor even limited to death. Actually, all kinds of phenomena can spread, and they spread well beyond just pairs of individuals. And that led to a series of interests and investigations, and ultimately in 2001 I moved to Harvard University, and then met James Fowler, my long-term collaborator, and then we started a whole bunch of projects.
You were trying to figure out how to measure whether behaviors can spread really widely in a population. And so you wound up finding the Framingham Heart Study, right?
Yes.
And so tell me a little bit about what they had done and how you're able to use that to find stuff out.
What we were interested in doing is we were interested in studying how some counterintuitive phenomena. So most people are familiar with the fact that fashions can spread, or germs can spread. But we were interested in a diverse set of other sorts of phenomena, sort of various human behaviors like weight gain, for example, or exercise behavior, or emotions. For instance, most people are familiar with the idea that there can be emotional contagion. For example, I gave a talk in New York City a few years ago where I said, you know how when you're on the subway and you're sitting in the subway car and the person across from the car smiles at you and you just instinctively smile back? And they said, we don't do that in New York City. And I said, well, everywhere else in the world, that's normal human behavior. So people are familiar with the notion of emotional contagion. But what James and I were interested in doing is we're studying a diverse set of other phenomena that were counterintuitive and, perhaps more interestingly, in understanding how they could spread beyond dyads. So not just from person to person, but from person to person to person, and person to person to person to person. And in these complicated networks, which had this lightning-type branching pattern, which is mathematically very complex. So we needed some data to do this, and the data we needed didn't exist at the time we had these ideas. And through a various serendipitous sequence of events, we happened upon some paper records at the Framingham Heart Study, a very famous epidemiological study that's been going on since 1948. And we were able to computerize those records and create the data that we needed.
And so you had this network of people. It was about 50 years, right?
Yeah, well, we studied 32 years of the data, but it goes back to 48, yes.
You had about 5,000 people.
15,000 overall.
15,000 overall, right? And networked, about 5,000 networked together?
More. We had about 5,000 embedded in a network of 12,000.
Okay. All right, and so you look at how they change over time, and you see clusters of them getting obese, for example, over time, and that was spreading from friend to friend, basically, and from spouse and whatnot. Obesity, you found spreading what other types of things? Happiness?
Yeah, we looked at a diverse set of phenomena. I mean, first we started looking at things like that were very public health oriented, like weight gain and weight loss, smoking behavior, drinking behavior, eating behavior. And then we started using other data sets as well, not just the Framingham Heart Study. There's a very famous data set known as Ad Health, which is about 100,000 high school or middle school and high school kids around the country. And then we started doing experiments, and we started collecting our own other data sets, and we broadened the scope of what we looked at. Eventually, we became interested in what I would regard to be very fundamental human behaviors like cooperation. And
altruism you studied too.
Yeah, altruism, cooperation.
So altruism does spread. Like if I'm altruistic, my wife and my children and my friends are going to be more altruistic.
We used some experimental data. We've done a whole set of projects on that now, kind of looking at the pay-it-forward phenomena. So what's interesting is not that, if I'm kind to you, you might reciprocate the kindness, and this is known as direct reciprocity. And that's interesting, and not easy to explain, but not too difficult to explain either. But what James and I were interested in is not whether I'm kind to you, then you are kind to me, but whether I'm kind to you, and then you're kind to him, and then he's kind to her, and it spreads through the network. And why? Why does that happen? Which begs a whole set of questions in evolutionary biology and, frankly, in human genetics. So that then led to another whole set of projects where we kept digging deeper and deeper. And in a way, if you think about I mean, one of the ways that I've come to look at human social systems is that we are a kind of human superorganism, you know, that we humans agglomerate to form something bigger than ourselves. We do this not just when we make groups or networks or nation states or communities or neighborhoods and other kinds of higher order structures. And we resemble in some ways other creatures that do this. The well-known example is ants, but there are certain fungi that make human superorganisms. And what we became interested in a way, for us, was sort of backwards. So first we started studying the physiology of the human superorganism, or the function. And then, as we were looking at things spreading within networks, we began to ask questions about, well, why? Why does that happen?
Why does this happen?
And what's the structure? What's the anatomy of the human superorganism? And that then led to a set of investigations on human social network structure, not just function, and then the deep origins of this structure. Why do we have the structure that we do? And so for the last 5 years or so, we've been doing a set of experiments and other investigations trying to understand why. Not only why do we make networks, but why do networks have the particular sort of mathematical structure that they do. And so that's what
because this stuff recurred over and over again. I mean, you found that no matter what you were looking at, you got an effect about 2 hops out, but then no further, basically?
Okay, so that's a functional, not a structural observation. One of the things we've observed is what we've come to call, in a kind of shorthand way, the 3 degrees of influence rule. So that everyone is familiar with the 6 degrees of separation rule, or observation, which describes network structure. Right. But what we became interested in was the observation that across a variety of empirical data sets and phenomena, it seemed that I could affect you, and you could affect him, and he could affect her, and then the effect kind of tapers off and dissipates
after 3 hops.
Well, on average of 3 hops. Sometimes it's 2, sometimes it's 4, sometimes it's none at all.
Right, yeah.
Like, not everything spreads. But things that do spread seem on average to spread to about 3 degrees of separation. And there are a number of possible explanations for this. This is not magic. I mean, one of the most obvious explanations is simple decay or friction in the system. So like if you drop a rock on a pond, the rock creates waves, but the waves don't stay at the same amplitude and go all, to the periphery of the pond. They dissipate, right? The water molecules have friction with each other. So something similar is one of the explanations for why that happens in humans. So, but that 3 degrees of influence idea is more an idea about how networks function and less an observation about how networks are structured.
Sure. Okay. So one of the things that fascinated me was thinking when I was looking at your work, realizing that there's some very interesting health implications to this. Because just as an example, when you looked at smoking, you found that as people in the crowd probably know, so there's been a lot of hard work getting people to stop smoking, and for several decades it worked. It was going down, down, down until we got to about 1 in 5, about 20% of the people are still smoking, and that it just
worse in young people.
Yeah, that's right. Yeah, and it sort of stopped there, and there hasn't been as much success in getting any lower. And there was sort of a mystery as to why is it that we can get it that low and not lower. And I remember when I looked at your research, it seemed to suggest an answer, because the smokers were clustered in networks that were not connected to non-smokers anymore. So if non-smoking is a contagious behavior, they can't catch it from them because they're not talking to. Is that?
I think that's one possible.
One way of looking at it.
I mean, I've been accused variously of being a bit of a zealot. I guess I am a kind of a network zealot. So when you have a hammer, everything looks like a nail, and so I always have to resist the temptation to see everything as a network phenomenon. Yeah. And of course, there can be many explanations for the same thing. Yeah, so I think there's probably a network story. But the way I would describe this is, so imagine you have a wedding banquet, and there are 10 tables of 10 people. And I tell you that every minute a bell's going to ring and 10% of the people are going to leave. Right. In the extremes, there are at least 2 ways this can happen. The bell rings and one person from each table goes, and then another bell rings and then one person from each table goes. And so the size of the number of people at any given table declines smoothly from 10 to 9 to 8 to 7 on down, and the total number of people in the room declines smoothly. But an alternative way that the people could leave the room is when the bell rings, everyone at one table gets up and leaves. Right. So then until the very end, all the tables have the same number of people. They have 10 people. So any table that has any body has 10 people at the table. So this is analogous to what can happen in networks where clusters of individuals change their behavior at the same time. In one scenario, you have kind of a smooth, kind of homogeneously distributed through the population decline in a kind of behavior, where everyone stochastically has a kind of probability of quitting smoking. Right. And in the other scenario, you have whole groups of smokers who are interconnected quit simultaneously, all get up from the same table and leave. so that by the end you may have a couple of tables, 20%,
right,
where they just don't get up and go. And there's nobody at the table
together.
Yeah, and there's no one at the table that's getting up and going to sort of stimulate their reflection. So there is a sense in which that can be happening. Yeah.
So what are the public policy implications of understanding health outcomes as being affected by these networks of people? Like, you know, if you sort of say, okay, so we know this, so we can see things like happiness, depression, divorce, I understand, spreading socially. How does that change the way we think about keeping people healthy, maximizing, you know, good health behaviors and minimizing bad ones?
So James and I call this our so what question. So we spend the first 10 years trying to figure out how networks, what is their function and their structure. And in the last few years, we've begun to turn earnestly to the problem of trying to figure out what can we do with this knowledge.
Right,
like, so what? How can we make the world better? And our first effort in this regard was to invent a completely new way of forecasting epidemics. And it'll take a second to describe this, but the gist of the idea is, imagine a network. Most people in the audience now have a kind of visual sense of these networks. If you have never thought of it before, it looks kind of like Christmas tree lights, like when you take them out at the new season and they're a big mess, and you kind of take the tendrils and you kind of try to untangle them, and you put these tendrils of lights, and there's a big mess in the middle. A network kind of looks like that, and things can flow across this network. And if I told you that a germ was going to infect one of the people in this network, where the lights are people and the wires between them represent relationships, you probably have the intuition that being in the middle of the network would be dangerous, because you'd be more likely to get whatever it is that's spreading and more likely to get it sooner. And so we took that insight and we said, well, what this means is that if we can monitor, if we can identify central people in a network and monitor them, perhaps using big data technology, the person in the middle should be more likely to get an epidemic disease before the average person in the network. So it's not just like right now when the CDC is trying to forecast an epidemic, it sits in Atlanta and it waits for data to come in from the field. Doctors and patients do their thing. Data gets fed through a pipe. It goes to the CDC, and 3 or 4 weeks from now, they know where the epidemic is today. Right. And then Google Flu Trends came out a couple of years ago where they said, well, we can look at people's searching behavior today, and we'll know where the epidemic is today by calibrating the model. But what our idea lets you do is it tells you where the epidemic will be tomorrow. Actually, it can tell you where the epidemic will be in 2 to 6 weeks in the case of H1N1 flu. Because when the middle people in the network get it, they're like sentinel nodes. They light up. You know, oh my God, this person has it. That means the epidemic is coming. So that was one of our first efforts, is to invent a new way to forecast epidemics. And this works not just for germs, but for anything that spreads, ideas, behaviors, norms,
and this was successful
product adoption.
At Harvard, right? You did this at Harvard.
So proof of concept was in a paper where we did an H1N1 outbreak in Harvard College students, but we've since done it in a variety of unpublished papers, which will be coming out soon, showing that it works online and in other ways.
And this is interesting. I'm sorry, I'm interrupting you, because a lot of what we've been talking about here at this conference is about the fact that you're looking at a network like, thousands and millions of people. And one of the things that's been happening here at the conference is people talking about individuals being able to monitor their own health and collect stuff themselves, but also send out signals. And it makes me think, well, this is really interesting. If you marry the ability of individuals to monitor what's happening to them with a network analysis that can be highly predictive, like if you knew those people in networks and they were wired up, you could have an unbelievably quick response.
That's exactly right. That's right. If you had, for instance, picking up on another macro trend in our society on citizen science, imagine that thousands of people in New York, it wouldn't take too many, a couple thousand, volunteered to wire themselves up and report when they had the flu. You could create a completely, and if you knew their network location, which you could get from phone data or email data, you would have a way in which the New York Public Health Department could know that an epidemic was striking New York City weeks before it actually struck. So you can marry a kind of individual level data and what James and I are calling small data. It's sort of old fashioned. There's like between like a single person and sort of big data, which has thousands. But I want to, before we run out of time, I want to pick up one thing, which is, so one set of projects had to do with trying to begin to invent new ways to forecast epidemics. The other big strand in our so what kind of question has to do with, okay, if you can understand how human networks are structured, and there's like a lot of interesting evolutionary biology that we and others have been doing to try to understand that, and sort of some other studies. But if you can also understand how they function, then you can begin to think about inventing new ways to target delivery of beneficial innovations in social systems. So we have a study right now that we've been doing in Honduras, where there are 32 highland villages, and we are, have mapped the networks in collaboration with some others, with Derek Stafford and Alex Hughes. We've mapped these networks, and then we have been targeting the delivery of public health interventions to specific locations within the network with the idea of trying to see, can we radically change and accelerate whether certain villages adopt certain public health interventions. So if you understand how things flow within networks, in principle, it should be possible to turbocharge public health behaviors, and incidentally, not just public health behaviors, but all kinds of other things. For example, if you understand doctor networks, the structure of physician networks, you should be able to sort of see how can you target innovation within networks of physicians to get doctors to adopt safety practices, or to switch to generics, or switch away from generics, or to reduce test ordering, or whatever it is that you're trying to change the behavior of this social system to do. An understanding of network structure should facilitate that.
Right, exactly. In fact, that made me think. I mean, I remember when what was the great stat in your original obesity study? I mean, if your friend becomes obese, you have a 57% increased chance of becoming obese.
Yes.
If a friend becomes obese, you're still got a 20% chance,
yes.
Even 2 nodes over.
Yes.
I mean, the really spooky thing also is it can skip nodes too,
yes.
right? Like if I'm friends with you and you're friends with James,
yes.
if I start smoking, James's chance of smoking goes
yes.
up even if you don't start smoking.
Correct. So people often ask about that, but it's not magic. We're not talking about action at a distance. And the best way to illustrate this point is to invite you to reflect on something like the flu. So right now, your friend's friend is sick with the flu and has the sniffles and infects your friend. You don't know your friend's friend, by the way. There's no backdoor path in this example. And your friend's friend infects your friend. Your friend's friend gets the flu, is a carrier of the flu, but doesn't evince any symptoms.
Right.
Then they spread the germ to you. So you have now directly, causally acquired the flu as a result of your friend's friend having the flu via the intermediary of your friend, even though your friend never had any symptoms of it. And similar things can happen with behaviors. For example, my friend can gain weight. They gain weight, let's say, because they start eating poorly. This changes my idea about what acceptable body size is, but I don't change my behavior or gain weight. I do nothing different. Now my friend over here, he or she quits their exercise regimen.
Right.
In the past, before I was exposed to this friend, I might have thought to say to my friends, you know, you're gaining some weight. Maybe you should not drop your exercise regimen or something horrible like that. But now that my friend over here has gained weight, I don't see weight gain as being problematic anymore, so I say nothing. And the lack of my intervention, let's say, facilitates or increases the risk that this person will gain weight causally as a result of this person, even though it didn't affect me. So things like that, kind of behaviors like that, or explanations like that can help explain the skipping process.
Given the fact that obesity has become a big issue in the U.S., has anyone ever come to you and had an idea for a network-based intervention that could actually help with obesity, since we understand this?
Yeah.
It's a difficult one to tackle, I understand. But.
Yeah, so there's a lot of work being done in a lot of labs around the country by lots of people that range in everything from focused interventions. If you think about like Weight Watchers, for example, it is a kind of artificially created network, right?
That's right,
You bring strangers together, you kind of create what is known as high transitivity in the system, so everyone knows everybody else, and then you seed the network with a desirable property, which is an ideology about weight loss, and then presumably it reinforces itself.
Right.
You can do everything from that kind of group formation and network manipulation type of intervention to broader interventions where you imagine targeting particular individuals within systems based on your assessment of how influential they are to try to get them to either not gain weight or to lose weight.
Right.
And Tom Valente and USC and lots of people around the country are investigating these types of interventions.
Great. I think we're right at the time now for questions from the audience. So have we got the microphone set up for that? All right, we've got a bunch of questions at the back there.
Hi. So I know, Dr. Christakis, you've worked with Framingham data and Facebook data. I'm wondering if, this is two questions. I'm wondering if there is, what kind of novel data sets you might be working with now. And then second question, what would your dream data set be? Like the one kind of big storehouse of data that you'd love to get access to?
Yeah, James and I have worked with lots of data, Framingham data, the Facebook data, the ad health data. We've also done work with some telephone data from a large European country where we had, in partnership with Laszlo Barabasi's lab, had access to data regarding telephone communications through like 40% of the nation. We have collected our own data from schools, like we just discussed, from Harvard students. Also, we did a project recently where we mapped the social networks of the Hadza hunter-gatherers. There are only about 1,000 Hadza left. Only about 600 of them live in the traditional way. They hunt and they gather for their food. They have no fixed possessions to speak of, no dwellings, no agriculture. And we were able to map their networks. And incidentally, the reason we did that is we wanted to test the claim that social network architecture is ancient. And in fact, Hadza networks look just like ours, which is, in my eye, a very interesting finding. So we've done lots of data collection efforts like that. And we continue to try to find ways to collect network data, physician networks, and so forth. My fantasy kind of data set, some of it is sort of in the big data vein, sort of Facebook data plus, linking Facebook data, for example, as James just did in his recent paper that was in Nature, with voter records, which are publicly available, or linking Facebook or other similar data, email data, phone data, to other information about the person, so you don't have such a thin data set. And this can be done either with due respect to everyone's privacy and anonymity, or by getting informed consent. So one of our ideas, again, picking up on the citizen science thing, is a kind of notion of creating an infrastructure so people can donate their data to science. So imagine you created a kind of platform where people could voluntarily surrender, with rules that they would agree to, some of their privacy. Just like you can leave your body for anatomical dissection, but now you could donate your data to science. And if you could get large enough numbers of people to do that, you could actually create a rather useful set of data. But a real fantasy would be to be able to find a defined population, a set of villages in India, for example, where you would systematically map the network of these villages and do so repeatedly across. Since I'm interested in networks, I mean, you could have other questions, but given the network interest, you would spend time to do that, coupled with detailed information about the individuals, to really understand the microdynamics of how innovation and ideas and behavior spread within social systems, with an eye towards inventing new methods to make the world a better place.
Okay, we have a question from the internet here. Can social network influences counterbalance, sort of mass marketing? Like, junk. In a weird way, you can think of advertising of, Frito chips as an attempt to intervene in a network, right?
Yes, and I would say, in fact, social network influences are vastly more powerful. So if you think about, the supermodels are just as thin as they ever were on the cover of our magazines. That's a mass market message that we send all the time. And yet, willy-nilly, we're all gaining weight. And we are much more influenced by the behavior of our friends than we are by these abstract ideologies. Or if you think about why do guards abuse prisoners? The guards know that we have a commitment to the respect for human rights and civil rights in our society, and we have all these abstract ideologies. But when the nearby guards start abusing prisoners, that overwhelms any kind of mass market kind of message that someone will get. So I think that the direct personal messages that we get, or you may read a Consumer Reports or some other kind of review, perhaps in Wired, of a product, but if your friend who is tech savvy recommends or fails to recommend the product, that's much more powerful than an advertising campaign or anything else. So we are definitely influenced by mass marketing, no doubt about it, but these social influences are, in my judgment, much more powerful. However, it's extremely important to distinguish online interactions from real interactions. So the way I would think about this is, when the telephone was invented, it didn't mean that any old schmo that called you with a phone, you would, because they used the phone, you would do what they said. The phone rings, oh my God, it's from the phone. And someone is telling me I should do something, and oh, okay, you're using the phone, I'm going to do it. However, if your friend used this technology to call you and said you should do something, then you would do it. So what matters is not the medium, it's who the person that's sending you the signal is. And it's the same on Facebook. Just because you can be connected to 1,000 people doesn't mean that if any old one of your Facebook friends evinces a certain property, you're going to just willy-nilly copy them. But if one of your real Facebook friends, among all those weak online interactions, does something, then that medium can accelerate your acquisition of the information and affect you. We have done a number of, and others, Duncan Watts and others, have done a number of projects exploring these ideas.
Terrific. We've got a few minutes left. Does someone have a very quick question that can be answered in like 30 seconds? All right, let's go for it. Let's try.
Sure. This is about the practical side of it. So in DC, we have all these problems in healthcare. Both, if you had the dream ability to say which one I wanted to change, what problem would you go after? And is anyone in DC interested enough to help you do that?
All right, you got 30 seconds, Nick. Go. All right.
I guess I'm going to give you a very parochial answer, which is I would broaden the problem and say that I'm really interested in the science of behavior change. How do we get people? Because I think that is a very fundamental and lies at the core of so many other health problems. So I'm not going to give you a specific disease or a specific problem, but instead I'm going to give you a set of topics. And as you can imagine, there's no single thing that you can do to magically change human behavior. It's a program of understanding and of intervention that's required.
All right, terrific. Well, thank you very much. Thanks, everyone, for coming out. Thank you very much for your time, Nick.
Thank you.
And if anyone, if you want to know more about his research, go to humannaturelab.net, and it's got tons of Nick's papers, fantastic work, really worth looking at.
And I'm on Twitter.
And it's on Twitter.
All right.
Take care.
Thanks, Clive. Thank you so much.